Okay. Next section again is nothing new. It's what we did in the last unit with completing the square, except this time we're using it to find our solutions. Before we just did completing squares to find the factor. Now we're going to take it that one step further and find our solutions. So for the square root method, it says when there is no bx term in a quadratic equation, we look first to see if it's a difference of squares. Is each term a perfect square, and is there a subtraction sign in between? If it's not a difference of squares, it can be solved by using the square root method. So it says the general form of a quadratic equation that you could solve using the square root method is ax squared plus or minus c is equal to 0. So basically you're missing that x term in there, or the term with a power, the variable has a power of 1. So example, it says solve 9y squared minus 21 is equal to 0. So it says get everything that isn't squared to one side, and then you square root both sides. So anything that isn't being squared needs to go over to one side of the equation. So we're starting at 9y squared minus 21. So what that means is we want to move, we want to move that negative 21 to the other side. So that means we're going to add 21 to both sides. So 9y squared is equal to 21. Okay, and then when you have everything over there that's not being squared, then you can square root both sides. But I still have, in this case, this 9 isn't being squared. Only the y is being squared. So that means I have to divide by 9 on both sides. So I have y squared is equal to 21 over 9. So now my squared is on one side, everything else is on the other, so I square root both sides. So this is step 1 was here. Now step 2 comes when I square root both sides. Step 3 says consider both the positive and the negative square root. So we've talked about this before. When you square root a value, you have two solutions. You have a positive solution and a negative solution. Sometimes we throw out the negative solution, but you still have to include it in part of your calculation. So for this one here, I'll have y is equal to plus or minus square root of 21 over 3, because square root of 9 is 3. So it says simplify any radical solutions as much as possible. So I actually did step 3 and 4 in itself, because I could have just written this as plus or minus square root of 21 over 9, and I just went straight to the solution. So that is my answer, plus or minus 21 over 3. So that only works, this method only works when you don't have that x to the power or variable to a power of one term. So in the next 3 examples, we're just going to do the exact same thing. So first of all, I need to take everything over that is not being squared, so that means I'm going to add 11 to both sides. So I have 2x squared is equal to 87 plus 11 is 98. I divide by 2, so x squared is equal to 49. I've got my squared all by itself, so I square root both sides, so x is equal to plus or minus 7. B, 50y squared is equal to 72. So I don't have anything to add or subtract, but I need to get rid of that 50 on this side. So I have y squared is equal to 72 over 50. Now they don't divide evenly, but they do reduce. If I divide both the top and the bottom by 2, I have 36 over 25. So now I can square root. So y is equal to plus or minus. Square root of 36 is 6. Square root of 5 is 5. So plus or minus 6 over 5. Okay, what about when you have a binomial? Well, it's no different than what you did before. You have to make sure that your squareds are by itself, and if they are, then you go straight to squaring both sides. So I have my squareds are together, or my squared is by itself, so I can go straight to square rooting both sides. So my squared and square root cancel, so I'm left with x plus 3 is equal to plus or minus 4. So that means for this one I have two solutions. Again, my one solution can be x plus 3 is equal to a positive 4, or x plus 3 equals negative 4. So I have my positive 4 solution. Oops, that should be going like this. And I have my negative 4 solution. So x is equal to 1. If I subtract 3, x is equal to negative 7. So my solution set, x is equal to negative 7 and 1. And I guess for these ones too, I could put my solution set in there like that. Okay, so those ones are nice and easy. When you don't have that middle term, then you can just use your square root method, and your solution is usually fairly quick to solve. Okay, but what if you don't? So it says sometimes factoring quadratic equations, like we did in the last section, 4.2 is not possible. Okay, so sometimes it's not as easy as just GCFing something and then doing product and sum, or difference of square, or doing the decomp or slide and divide. So it says that you cannot find the two numbers that multiply to C, or A times C, and add up to B. When this is the case, you can still solve the quadratic equation by a method called completing the square. So in last unit, we did that to change something from standard form into our vertex graphing form. And vertex graphing form, then, when we're doing it this way, puts it so that we can continue on to doing our square root method. So it says, solve x squared minus 21 is equal to 10x by completing the square. It says this example can easily be solved by factoring, but we will use it to introduce how to complete the square. So this is actually one example where you could use a product and sum and find your answer easily. So what we want to do with this one, and this is where it's a little bit different than when we did it in the vertex graphing form, in one of the steps that we do. So what we want to do for this one, when we're solving for the equation and not just putting it in vertex graphing, is we want to get the c to one side of the equation. So we want to get c by itself. And we kind of did that in the other one, but we just added or subtracted it onto the end of the equation. In this one, we're going to move it to the other side of the equation. So if I rewrite this, it's going to be x squared plus 10x minus 21 is equal to 0. So all I've done is move my negative 10x over, so everything is on one side. Now what we want to do then is to get the c over by itself. So that means I have x squared plus 10x. I'm going to move my 21, so I'm going to add 21 to both sides. So plus 21 plus 21, that takes care of the minus 21 plus 21 cancel on the left side, and then I have 21 on the other. So then it says in step 2, if the a value is a 1, find the b, have it, and square it. So in this case, my a is equal to 1, and my b is equal to 10. So since a is equal to 1, I'm going to take my b value, have it, so divide it by 2, which leaves me with 5. And then I square it. So this is exactly what I did before with my b value. My c is the only thing that's a little bit different. It's moved over to the other side. So then it says add the number from step 2 to both sides of the equation. So my 25 from here that I got by having and squaring, instead of adding it and subtracting it to the same side, I'm going to add it to both sides of the equation. So I have x squared plus 10x plus 25 equals 21 plus 25. So what I did before, and I'll just do it over here, I did x squared plus 10x, and then I went plus blank minus blank, and then I would have had a minus 21. And then if I continued with that, I would have x squared plus 10x plus 25 minus 25 minus 21. So this here would give me a negative 46. But if I bring that to the other side of the equation, it's a plus 46. I really haven't done anything overly different. I've just moved it to the other side of the equation. So my x squared plus 10x plus 25 equals 21 plus 25. So in my step 3, I have added the number from step 2, which was here, to both sides of the equation. So what I have on the left side is that perfect trinomial square, so I can factor it. So this becomes x plus, and remember what we used to do before is we'd say we'd keep that half value. So x plus 5 all squared is equal to 21 plus 25 is 46. So in vertex graphing form, this would have been y equals x plus 5 all squared minus 46. But because I'm solving the equation, I put that 46 on the other side. So now what I have is exactly like that example example C from the last page where x plus 3 squared equals 16. I have x plus 5 squared is equal to 46. So now what I'm going to do is I'm going to solve using the square root principle. So step number 5 tells me that I have to get my squared value by itself, which I have, and then I square root both sides. So squared and square root cancel, so I'm left with x plus 5 is equal to plus or minus square root of 46. So square root of 46 isn't a perfect square. We can't multiply out the perfect square from there, so we just leave it as plus or minus 46. So that means that my solution for this is x is going to equal, I have to subtract 5 from both sides, so negative 5 plus or minus square root 46. So you could write it out as x is equal to negative 5 plus square root 46, and x is equal to negative 5 minus square root 46, or you could just leave it like I had it here. Okay, so these next two examples are exactly like what we did in the first ones. I'm just not going to number the steps as I'm doing them. The question says to express the solutions to example B in exact form. So in exact form means you don't work it out into a decimal, you leave it as is. Okay, so my step number 1 is I need to take my C value, which is my minus 11, and bring it over to the other side. So I have w squared minus 4w is equal to positive 11. If my a value is equal to 1, which it is in this case, a is equal to 1, b is equal to negative 4. So if that's the case, I take that b value, and I have it to get negative 2, and then I square it to get positive 4. So I take that 4, and I add it on to both sides of the equation. So I have w squared minus 4w plus 4 is equal to 15. This is a perfect trinomial square because I made it into that, so I know my factor is w minus 2 all squared equals 15. So the square root property says get your squared value by itself and then square root both sides. So I square root and I square root. Those cancel. I have w minus 2 is equal to plus or minus square root 15. And again, I can't change my 15. It's not a perfect square, so I leave it as is. So w, if it's minus 2, I add it to both sides, is equal to 2 plus or minus square root 15. And I would just leave it like that. B says x squared plus 5x plus 7 equals 0. So same first step, I have to move that 7 over. So I have x squared plus 5x is equal to negative 7. Okay, so my a is a 1, my b is equal to 5. So I have 5 divided by 2 is equal to 5 halves. Remember, we're doing this as exact, so we don't want to decimal it. And then I square it to get 25 over 4. So that means I'm going to do x squared plus 5x, and then I add that 25 over 4 to both sides. And remember, this half value we want to keep. So my left side is a trinomial square at x plus 5 over 2 all squared. Now negative 7 plus 25 over 4. If I want to change that so it's a denominator 4, I have to multiply by 4, so I get negative 28. So I have negative 28 over 4 plus 25 over 4. So x plus 5 over 2 all squared is equal to negative 3 over 4. So now I have my square root on one side and my square root on the other. So square root property says square root both sides. So my square root and square root cancel, but on the other side of the equation I have a square root of a negative 3 over 4. And we cannot square root a negative value. So this means there's no solution to this equation. So what this is saying is when y is equal to 0, if we think of this in the graphing vertex form, our graph is never going to cross the x-axis. So it means it's going to be going above the x-axis and facing up. It's not going to be a downward graph. So that's all there is to this first part with the squaring and square rooting property, or completing the square and square root property.